We microencapsulate a healing agent, which in this case is a liquid metal. And once it's encapsulated, we disperse it in a simple line of gold. And that's representative of all the circuits that you rely on in your cell phone. One aspect of this work that I think is important is that you can have devices that last a lot longer. It's more sustainable. We use less resources to produce those things. Traditionally, up to this point, if you wanted to conduct electrons, let's say, and establish a circuit, you developed a material that was perfect at conducting electrons. And if you also wanted that device to handle mechanical load, then you put that perfect conductor onto another perfect material that conducts load. And if you wanted it to sense, then you would develop a sensor that you would also put onto that material system to do all these different functions. So each function had a separate material system. The idea that we have is, let's build one material system that does all of these things in an integrated fashion. And by the way, at the same time, let's give it some biologically inspired types of functionality, like healing. So designing materials from the ground up, from really atoms up, to do multifunctional behavior is, I think, the wave of the future. So when this circuit is damaged, there's a crack that will open up and separate the conductive pathway. It ruptures these capsules and they release the liquid metal, which then flows into that gap and creates a conductive pathway and reestablishes conductivity. What's really fascinating about this process is that it happens so quickly, on the order of 100 microseconds, 100 times 10 to the minus 6 seconds. So it's so fast you can't even see it. And you need special equipment to actually detect that there was a failure and a restoration process, a healing process that took place. And that blows my mind because it happens so quickly.